Well, hello everyone. My name is Giacomo. I'm an Italian developer. I do quite like functional programming, though that is not the topic of today. I'm helping build what I think is a very cool open source project. It's called Gleam. It's a programming language. If you're curious about it, let's have a chat about it later. But we're here to talk about databases today. So, talking about databases, of course, maybe, I don't know, our marketing department or whatever, marketing advertisements, they want us to make beautiful graphs and crunch data because, of course, they do. They need that. And so it's up to us to then go fetch the data and figure out all the data crunching and data wrangling that we need. Or maybe we're just building something for our friends. Well, I do love reading. I have a book club with my friends, and of course, being a nerd, knowing how to code, I had to do something with all the data that I was gathering from them. And so here we are. We have books, they have genres, we rate them, and so on and so forth. This is really just a simple example. But it doesn't really matter what you are building, because when you are dealing with a database, well, that will come with the age-old question of, how do I talk to the database? How do I get the data out? How do I do the data wrangling? And answers might take entirely different looks. On one end of the spectrum, we might be writing SQL, totally fine. At the other end, we might do something quite opposite. We want to abstract it away, to even hide the fact that SQL is there, using fancy tools like ORMs that shield the developer from ever having to write any line of SQL. That can be pretty cool as well. And usually as developers, when we are faced with this kind of choices, we like saying that a developer should really be a polyglot. We should be using the right language, the right tool for the job. We like that because that allows us to then advocate for the language we prefer. Of course, we should be using Java or Python or, oh, not really the Java audience, I see, okay, or Gleam, for example, because that is a great language and we should be using that. But, well, it doesn't really matter. You could put any language in there. I think that the right tool for the job, when it comes to talking to a database, well, that is SQL. That is the language meant to be talking to the database. So it has some really nice advantages. I think this is quite the nice crowd to give this talk to because I won't find much pushback saying that SQL is good. It makes us more intentional about how we are implementing our specific workflows. Because we can see that we're implementing something using, what, one, a pair, tens, hundreds of different queries. And then we can see that we're doing something that is inefficient. Usually we want to do as much as possible with as little round trips to the database as possible. And being the ones that are writing the queries, rather than having them generated under the hood as an implementation detail, puts us in the control spot where we can decide how to do something. So it's also a lot harder to overfetch data because we are the ones who need to be writing select star overfetching the data. We can catch that pretty easily. And I was reading a cool article, scaling PostgreSQL to power 800 million users, and this company was facing most of its problems with some problematic queries coming from ORMs, and they ended up having to then inspect those and see what was going on, understanding what was going on under the hood. So not really an implementation detail at this point when we need to have a look at it. So if using SQL, I'm not saying it's going to magically make our applications faster, but it kind of drives us towards this bit of success, where it's easier to do the right thing, to not make something that is terribly and woefully slow without even noticing. So if SQL is so good, then where is all the SQL? Why do we feel like we need different tools? Why do we feel like, as developers, we need to abstract it away? Well, when it comes to writing an application, we usually do that in a different language. This is what it might look in Gleam, for example, to run a query. It doesn't really matter how it does it. If you squint hard enough, it would be exactly the same in, say, Java, for example, seeing that you love it. So what happens is our query becomes a string in our programming language. One first drawback is we lose syntax highlighting. And then we need a way to bridge this gap between the relational word, where we have tables with rows and columns, and the word of our application, where we might have objects, data structures, or whatever we might use to then represent some domain concept. And so we need to tell it that, for example, here, the first column ISBN that is a string, and we're going to use that as the book ISBN indeed. The second column is again a string, that is the title, and then we're using it to build this book data structure. It doesn't really matter how Glim does it. And this might look totally reasonable, as long as we don't start writing more than just the simplest of the queries. Because of course, then requirements change. Maybe we need to fetch more data. Maybe someone comes and does a refactoring. They switch columns around in our select query. Well, that might look silly, but I guarantee you, if something can happen, it will happen sooner or later. And then now we have some really hard to find bugs, because the decoder we've written, saying that the first column is the ISBN and the second is the title, is no longer right. And when do we start seeing these errors pop up? Well, if we've been diligent and we've written tests, those will happen in our test suite, and we'll see something fail, hopefully, if we have a good coverage. Otherwise, those are going to happen in production, where things suddenly go wrong, and then we get paged and we need to figure out why something broke. Not really a pleasant developer experience. So we start from a place where we're thinking about the data that we need, and really what we want to do is we want to fetch and use it. That's it. Of course, we need to write some SQL to do that. But now, going from SQL to fetching the data is not as simple, because we need to write some glue code, the decoding logic that bridges the gap between these two words. And then finally we use it. But glue code, well, it's in the name. It's sticky. It calls for more glue code, and then we find bugs and we need to go back to writing SQL, and then we need to write again some more glue code. It's really painful. No one wants to do that. So what should we do? Should we just give up? Accept that as nice as SQL is, well, it's not the right language when building real-world applications. Well, of course not. You know the title of the talk. You do not need an ORM. So SQL could be the right language for the job. What would it look like, then, to embrace SQL rather than trying to abstract it away, treat it as an implementation detail? Well, what I would like to show you, what if, calling a query was as simple as calling a function or a method if you're doing object-oriented, because then we know how to do that in our language of choice, whatever that is. We deal with the data that is coming from the database. We know how to code in programming language X that we like. So I would like to show you a library that tries to do exactly that. It's called Squirrel. I'm the author of this library. Really, it's not the first of its kind. There's plenty of libraries that do this in many different languages. This is thought for Glim, though. And I think the best way to get a sense for it, because this might sound a bit hand-wavy, what does it look like to embrace SQL and have a nice developer experience? Well, it's with a live demo, which is quite scary to me. If someone could hold the microphone so I don't... Can I just... Okay. Thank you. Okay, so let's jump right in. So here we have our project. And what it means to embrace SQL is we're writing our SQL queries just in plain old .SQL files. As boring as it can be, but as nice as it can be. Because now we get, well, syntax highlighting. We get the help of IDEs. We might be using an entirely different one. Here I'm using, for example, data grip. I think it's quite pleasant. It could be anything, really. So here we're building a ranking of books. So we are giving a number to each book based on its rating. Number 1 is going to be the best, and so on and so forth. Say we want to make this a tad more complex. We can turn it into a subquery, call it ranking, and only get the best 3 books, for example. So where the position is less than or equal to 3. Maybe we want only the covers of the best 3 books for each genre. So let's group by genre. I don't think a subquery is all that nice to read. Let's make it a common table expression. Much better. Now we see that we have a warning. Select star, avoid that, because that is overfetching data. We never want to do it. We want to be precise about the data that we send to our application. So let's just select the genre, and we wanted to do an aggregation, so array aggregation of the covers. And just like that, we have a cover image, maybe, as covers. And just like that, we have something really nice, and and basically, the IDE was writing this for us. We have refactorings, we have auto-completions, we can move code around pretty easily. SQL has been around for a long time, and these tools have been developed to making the experience of writing it really nice. But again, this is just a SQL query. So how do we actually run this then from our application, from our Gleam code in this case? Well, to do that, you would add the Squirrel library as a dependency. I've already done that because I don't trust the Wi-Fi. And then we can just let run the Squirrel entry point. And just like that, you can see that something has happened. It says generated one query. So Squirrel is doing, under the hood, just some pretty straightforward code generation. I'm saying straightforward, it looks straightforward, it's actually pretty involved. But at the end of the day, what really matters is that what it does is it's understanding our queries, talking to the database, and figuring out what is the shape of the data that we're getting back, so that it can generate those decoders, that glue code, that now we no longer own because it's taken care of by Squirrel. So it can see, for example, that this query we've written returns rows that contain two columns. The genre column, that is a string, and the covers column. Look at that. That is a list of strings. We did an aggregation, and it could figure that out pretty all right. And then it defines a function to just call that simple query. And it is exactly the code I showed you earlier. Nothing fancy going on here. But now it is the one that is taking care of actually making sure that this is right and stays in sync with our database. So what this looks like when then we are developing our application is we write the SQL query, and then just like that, we can start using it. So we can call the function, and we're good to go. We don't have to deal with any other really boring glue code and maintaining code that is really not important. And since now everything is nice and type-safe, we can get the best tooling help that we want from our language. In Gleam, for example, I can automatically match on all the cases we see when talking to a database. We could get an error. Well, I will not bother with that. Here I'm making something pretty straightforward that I could manage in our live demo that is pretty short. We are just server-side rendering some HTML. So what we could do is we make a list, and then we transform those rows that are coming from the database. So we get those rows, and we turn those into maybe a list item. So now this doesn't exist, obviously, but since the language and the language server now can understand what we're dealing with, we get a lot of help from the language server. We can generate this automatically. We can automatically pattern match on this to get the data out. We can then start writing some more code, making the list item we said we were making. So let's build maybe a title with the text that we want, the genre, for example. And then another list, a list of covers. So let's do that. So here we can transform those again. We can get those covers, and we get help. Those are a list of strings. And we turn each cover into an image, maybe, to make something that is nice to look at. We generate it again, and we're good to go. So one final list item, and this contains an image. So let's do this. Source, and that is that cover that we have. And just like that, we're good to go. We could just focus on what we wanted, making a nice-to-look application. And so what we have here, if we run it, maybe, let's see if it works, fingers crossed. Perfect, seems like it started. And look at that. Okay, pretty all right for what I could manage in our live demo. And we have the books that we're fetching from the live database that is running on my machine. Okay, let's get back to our presentation. So we have a really nice developer experience here because we're dealing with just plain old SQL files. And now also think about this. The data that you have is going to outlive any application that you're going to build on top of it. So if you get tired about Squirrel and Gleam, that would make me really sad, but you can switch to any other language, take those SQL files, and you're good to go. You're not getting locked in by a specific language, a specific framework that then you have to keep using to reuse that code. Errors start happening at build time. The feedback loop is really tight. If we make a typo in our query, well, we're going to see the error right in our terminal as we generate the code. Hopefully you can appreciate the effort that I put into making that look nice and presentable. And so now it's a lot easier to deal with that. We started from a really bad place. We had to deal with a lot of glue code. And ORMs, don't get me wrong, they can have a great developer experience because they take care of those two steps below. Don't care about the SQL, you don't have to care about the glue code. pretty happy, pretty all right. But I think that abstracting the SQL away is a recipe for applications that are slower, not as performant. So what if we want to embrace SQL? Well, we can just let tools do the boring job, take care of that glue code for us automatically. And so we can stick to the best language for the job at each step of the development. We write SQL when talking to the database, and then we use the language that we know and love, Gleam for me, or whatever other language you prefer, when you're building your application. And so that is why you do not need an ORM. My name is Giacomo. I thank you so much for coming here today. If I can steal 30 more seconds, please consider sharing your feedback. If you like this, let me know. That would make my day. If you didn't, let me know how I can improve this so I can make this better. If you want to keep in touch, I am on social media. You can send me a good old-fashioned email, or you can, of course, this is open source. You can have a look at Squirrel.